All right. Hello, everyone. Welcome to assignment 2. I am Nicole Freeman, and we will be using SPSS to compare data. We will be looking into running a t-test, but still using our enrollment from 2 different regions and our data set from assignment 1. We want to understand the variance of correlation between the 2 regions. In our hypothesis in the data, we are looking at the null hypothesis that there is no significant statistical difference between the 2 regions. Our alternative is obviously that there is a significant statistical difference. What our hypothesis, we will be discovering if there are anomalies or patterns that include or indicate some discrepancies between the 2 regions. So our first step here is to pull the data that was provided through the actual assignment. So I actually already have that up in SPSS. And you see right here, we want to look at enroll. Currently, though, you can tell I have already omitted 2 through 4, but I'm going to tell you quickly how to do that just to keep us on the same page. What you do is go to data, you go to split cases. We're going to click region and then if then, which is already clicked for us because I did that task. And then you just click OK. And again, we'll see that it is omitted from that step. Now we're going to get to a little bit more of the fun part. We're going to start looking at the data. We'll look at our descriptive stats and to include standard deviation, mean, and other look-fors. We'll also use histograms, which I really like because they give a visual representation of the data and they can show normality or lack thereof. So we're going to go to Analyze. We're going to Descriptive Stats, and then we'll click on Explore. Now, once we're on Explore, the dependent list is enrollment. So we just click it, move it over, and then of course you have to have your factored list, which will be region. Because I said we're going to look at histograms, we also need to click plots. And right here it's stem and leaf. We want the histogram. But we also want the normality plots with the test. So we click that right here, and then we're going to click OK. And then we will click OK again. And look at that. It's just beautiful. Oh, it's beautiful, beautiful. But I do see that I have forgotten to put the bell curve on here. So in order to do that, I'm just going to right click it. Well, not right click it. I'm going to click it. And then I'm going to go to double click it and then go to elements, which mine is not wanting to work for me today. It's all the way at the top. Show distribution curve. Let me move all of these out normal. And we're going to click up normal and apply. Telling you it does not want to work today. Let me try that again. So we'll go elements. Oh, look at that. It's on there. See? Then you just exit out of this one. It actually will show up on the main one. Then we're going to do the same thing here. Click that, go to elements, show distribution curve, normal, and apply, and you see it is there. All right, and then we will click out of that. And again, now all my data is here for the most part. There's a few more things that we will run. Let's see. I'll just run through some of this real quick. All right, so we'll come back to the data. We have our case summary, the descriptives, tests of normality, which that we will be looking at. And then we're going to also look at our bell curves. But in order, we need some additional information. So once again, we will have to go back to analyze. Now we're going to need our actual t-test, which was the main part of this task. So once we go to there, we're going to compare means and proportions, independent samples test. And you see, once again, we have our variables that we need to separate. So here, after we've clicked that region 1 and region 5, you see the questions will come up. So this will be region over here. Maybe doesn't want to go. This is enroll, and this is region. Give me 1 second. Let me read my notes again. We need to set our variables, region 1 and region 5. So let's try this again. Let's take this out. region. There we go. And then it should pop up right here, define groups. I know I need to do the homogeneity test. So I'm not sure what I'm not doing correctly here. Enroll. Options, that's correct. Continue. Let me see if I cancel and try this again. Analyze. I want to go to compare independent samples t-test. And then right here, we want to put our test variable is enrollment. Move that over. Is region. Define groups. One is group 1 and 2 needs to be changed to group 5. All right, now we're talking. And then we're going to click homogeneity test. And I'm not sure why it's not letting me get a variable. That's correct. Enroll. Oh, there it goes. That was really weird. And we click OK, and now you can see our independent sample t-test. And that information is correct from the first few times that I've actually ran this assignment. All right. Now we're going to go back to actually all our data, and we're going to start at the very top because there's something that we need to point out. So right in represents sample size, 72 in region 1, and then 23 in region 5. It needs to be stated that 23 is under the suggested number of 30. To get a true accountability of data. In region 1, I'm going to pull this right here. You can kind of see our mean is 2353. You can see our median is 929. Our standard deviation is 4005 plus or minus. That's pretty high. And then our maximum enrollment is 21,962. And our minimum is 342. So a wide variety of districts in region 1. In region 5, we have a mean of 987. You have a median of 998, not that far off. And then our standard deviation is only 490. And you can tell like those must be a much smaller school district. All right. Now let's keep going. Test of normality. Um, Degrees of freedom. So this was something interesting to me because I'm thinking like absolute value. I know that's elementary math, but this is just the number of data pieces that they actually have. In terms of normality, you can see that it's less than 0.05, which indicates a significant difference. And then we see 0.0186 with less variance for region 5. And this is much clearer. Basically, it's showing variance, but it's much clearer on the bell curve. Typically, you want everything to follow the bell curve. And as you can see, our data points are not following the bell curve. However, on region 5, it does follow it a little more, but there's definitely some information that falls on the outside of the bell and some that fall short of the bell. All right. In our stats, you see the mean and average, which we went over. And then let me go right back up, find our one that we're looking for here. All right, in our group stat, so mean, you can see the mean between the two. There's a large difference between the mean. The standard deviation is significant too. The error tells what plus or minus you'll add to the standard deviation in order to find those data points. In our homogeneity, that is such a hard one to say. You see we are at 0.011. That demonstrates a high variance because it's again less than that 0.05, which tells us we're going to look at our equal variances, not assumed. And you can see right here, there's a significant difference between the two regions. They are not equal. In the t-test score, again, which is where I'm looking at currently, you can see that we're at 0.006, which again is 0.05, which indicates that we should reject the null hypothesis. The 2.8, and this is a question that I might have for others out there, is this represents that there is some variance, but I wonder what the cutoff score is. All right, and this is how you use SPSS to run a t-test, a homogeneity test, a normality test, and all of those things. Hope this was helpful.